So here we are in the middle of Silicon Valley. Where does it start? Where do we end? Big questions. And it occurred to us that it was important for us to start this series that's essentially about the new and developing technologies. The next session occurs on the 23rd of January with some lightning talks by members of our staff and the campus community who are involved with us in our AI studio. There'll be a bunch of relatively small-sized projects that begin to make clear how we are beginning to engage ourselves with these technologies. The talk today will be a brilliant example of how very high-end, very advanced, very cutting-edge leaders in the field engage and have their staffs engage with these technologies and thus eventually with us through the services they sell to us. There'll be a couple of dialogues on this question as part of this series. On the 5th of February, Jessica Riskin and Osama Khatib will discuss the human-machine collaboration. Jessica Riskin, a professor of history, current chairman of CLIBE. We're very grateful for her service. And on the 4th of March, Professors Peggy Phelan and Manish Agrawala will address the human-machine interface. So we continue to think about all these matters as we go forward. It's my pleasure to introduce Ruggero Gramatica, who is the CEO of UNO, the service that we present for discovery by concepts, not by keywords and key phrases. He is a great friend of mine. We've been involved together in several different contexts since 2010, which in retrospect seems a short time, but the actual distance intellectually that we have traveled together is most intense and I would say vast from my perspective, not from yours. He has a PhD in applied mechanics, mathematics, which he at some point described to me as econophysics, but he realized that I was incapable of understanding econophysics. So this other application is something that I can hold in my head. He has an MBA from University of Chicago, the Booth School, very fine school of business, an engineering degree from the Politecnico di Milano, and a certificate in quantitative finance. His business experience, like his academic pursuits, is as impressive. He has over 20 years of experience in startups and company turnarounds. He brings strategic leadership as well as technological and operational expertise to bear. He has contributed to the growth and expansion of 5 successful startups, both in the United States and across Europe. He has operated successfully in both blue chip and early stage environments. We have engaged, Ruggero and I and many of his colleagues, in passionate discussions, I would say even more than passionate actually, around information, knowledge, and discovery. And it's really wonderful to have someone in the business sector so attuned to and interested in our work as research libraries and librarians in support. So join me now, please, in welcoming Ruggero Gramatica, who will present.
Thank you, Mike. And I believe that I will need to start now with kind of playing down a bit more what Mike just said. What is true is that Mike and I go back to about 10 years, and there'll be quite an intense 10 years, and we're both living in 2 different continents, but yet very much involved on a couple of very interesting projects. And that was the inception point where I got very much inspired by Mike Keller depth of knowledge of what is information, what is the nature of providing information to students in faculties and research. And this is where we started thinking about, this is not research anymore, it's not search anymore, it's about knowledge discovery. And knowledge discovery is quite different. And I would say that we are living in an exciting moment and an exciting era. We are abandoning the information economy, which had been dominated for maybe 50 to 60 years, where all information was made available through public and private databases or collections. Even the advent of internet is about accessing information. We're entering into the knowledge economy, It basically is about making sense of the information and make us knowledgeable. So I will go through a talk and a presentation that I put together specifically for this event and for another event that will happen in about a week in Norway, in Oslo, where we're going to walk through the new ways how we should really think about information, and we should really start thinking about knowledge. It is not anymore to access a piece of information, but it's about understanding what it's all about. So knowledge. Knowledge is this big word that starts from the basics, epistemology. It is the theory of knowledge. It is the methods, the scope, and the way how we rationally put together our beliefs. And knowledge, in turn, it is a collection of elements, most of the time cognitive element, that drive the understanding of facts, information, description, that acquire through experience since we are kids, and we grow older and we assimilate and accumulate experience and information. We put them together. It's about perceiving, sensorial, not just reading. It's about discovering a beautiful world and learning. So that is what makes us knowledgeable. So we said discovering, right? Discovering is quite different from searching. We all agree that the difference between search and discover is I'm searching when I know pretty much what I'm looking for. I ask the what. I try to pose relatively simple questions and I'm trying to get a list of results that will drive me into delving into this element and get knowledgeable about something. Discover, conversely, is about try and recognizing that what you don't know has to be discovered and surfaced and unearthed. We need to ask the whys. We need to pose a thoughtful question and hopefully leads to new discoveries. There was an important panel at the Davos Economic Forum a couple of years ago, where basically they touched upon a very important point. Search engines, the most sophisticated or the most trivial, are quite good at processing and indexing documents, content per se, and returning a good solid list of the content available for us to read through. But they understand very little about the content itself. There's no exactly knowledge extraction. But what if there is a system or a new framework that goes into the content, the semantic, the understanding of what we are reading and what actually is made as available? If the search industry is about $10 trillion, imagine what a knowledge system, a knowledge discovery system could be worth in the next few years. So the overview of this presentation is about to present a cognitive framework that unify different areas. And the different areas will touch upon cognitive studies, computational linguistics, graph theory, and deep learning. When I say computational linguistics, which is one of the fundamental elements of which we are working on, it is something quite different from NLP, the natural language processing that most of you have been come across at some point, which is about understanding the keywords, the frequency of keywords in a given text. Computational linguistics goes very much into the understanding and the concept. You will see, hopefully, some fascinating experience throughout this presentation, how we work on this. And I'm proposing with this to every one of you imagine a new species of animal, an ant hawk. What's an ant hawk? It's something half hawk and half ant. Something that is able to grasp the entire landscape, so the topic, the domain, but yet being able to reach down to the empirical level and understanding the granularity of the information. The problem, we all know what it is, right? It is over and over again, too much information, but it's not just too much information. It's about that the information is too dispersed and too fragmented. Even though we know that there is one place somewhere in the universe or in this earth that all the information of a specific domain is there, unfortunately, that is too much for us to make sense of it. But unfortunately, there's not even such a place where all information is condensed and concentrated in there. And even more so, information, as we discussed, is not the same as knowledge. You know, we can access the biggest library in the world, we can get access to the biggest database in the world. That does not make us any knowledgeable at all. And how can we then make sense of information? How can we extract knowledge? So what distinguishes knowledge from information is a very cognitive component. That is quite fascinating, right? We are really entering into the cognitive type of studies. Knowledge does not exist per se, right? Knowledge is something that is individually on our mind. We're not born that there is a knowledge that we go and buy at the shop and becomes ours, right? Knowledge is formed through many years of cognitive processes. So cognitive is an active cognitive capacity that empowers us to act upon certain things, whereas information, albeit is very important, is a passive component. And in fact, how can we then extract knowledge from information? Well, the knowledge is something that is built upon fundamental blocks. You know, you have raw data, and when you aggregate raw data in a certain way, you have information, something that we can start using. When we apply certain cognitive component on it, then we have knowledge, and that hopefully make us wise people. In order to capture this difference and this shift, we need to basically use different tools of what we're used to do over the last 50 to 60 years. And it's about artificial intelligence. And I will spend only 2 slides here talking about this horrible word that means, and it's very often is abused because it means a lot of things. But AI has been around since the 50s, more or less, and very complicated to deal with, very complicated to formalize models, and it was just only to tackle for very specific complex problem. And over time got better and better, but never actually resolving real big problem, and not for sure at the hand of everyone. That was called as the AI, the winter of artificial intelligence. Luckily, in the years 2005-ish, with the advent of computational computing or the cloud computing, so when we had like power at our hand, there's been a shift, and new algorithms and new mathematical models came in out, and that is called the spring of artificial intelligence, where cognitive processes, machine learning based models, neural networks, and more recently deep learning, are indeed a very useful instrument to tackle the problem of knowledge extraction. Simply put, a neural network, that is one of the typical way to implement an artificial intelligence framework, is a mathematical model. Like all mathematical model, works with certain data in input, like mimicking the human brain. It works exactly the same way. And there is a function that processes this information and spit out something else, which is the output. This is actually, by the way, how our brain works, exactly like this. And incidentally, we can do exactly the same on computers. We can recreate neurons very simply with, could be the trivial one that just make like a summation or even more complex functions. We stack them up in layers and we have a neural networks. And that is still quite difficult to manage, to deal with, much easier than it used to be, but at the same time, very powerful. We said that the knowledge is formed in our mind, right? So many of the human cognitive abilities are articulated from knowledge acquisition since we were a kid, and over time, by patterns and samples and models, we put together a path of knowledge that make us knowledgeable about anything and any subject. How do we see ourselves in the surrounding world? How would we solve problems from the simplest to the complex one? How do we understand the meanings? And how we make deduction. So there is a problem of how we represent knowledge. How do you describe knowledge then? Okay, it's a cognitive process with data that I aggregate, but how do we do it? Well, knowledge can be represented through, at this stage, in a kind of computer science way through a new discipline called computational cognitive linguistics, and is how language and symbology forms our thoughts and knowledge is gained in our mind. And thanks to the seminal work of two professors, Peter Gardenforth and Ray Jackendorf, which for the first one, they basically, for the first time, they tried to describe a model of a knowledge representation. And we followed that path and we constructed, and we went even beyond that, a framework that basically follows the assumption that our minds organize information in knowledge and can do this through conceptual spaces. So imagine that we all kind of are animals with a kind of visual way to learn and to reason, right? And that actually, there is actually a proper reason, right? Because our mind works with topological type of patterns. And according to the cognitive tradition, meanings are mental entities. How can we condense mental entities and project them into a conceptual space? Quite interesting, and quite recently, a Gallant Lab at Berkeley University, they have run a project. They got about 25, if I'm not wrong, volunteers. They stuck them into an MRI machine while they were watching a movie, and they tried to observe what happened in their cortex. They were trying to hunt for this conceptual abstraction, how our brain structure concept by just visualizing something or reading or hearing. And it's quite interesting, you know, the way how it works. Like a typical brain of one of these patients, after watching this movie, is that the cortex memorize and store concept, so not words, concept, and quite in areas that are consistent with one another. For instance, here in this kind of green one, all the concept pertaining what they were experiencing at that time were about concept pertaining container, thick, sturdy, tube, inch, plastic, pipe, cloth, cutting, pounds, fabric, something physical, something tangible, right? And if you click all around, it's quite interesting. You can go online. Here's the URL. You can play with it. You can really understand how our brain, well, understand, it's not really very understandable, but you can see how our brain collapses a certain type of categories of concept in the cortex of that brain. So we thought we are on the right track. It is about concept, so it's not about words. When I read about something, when you hear about something, when you watch about something, your brain captures the essence, so the concept, right? Not very much the details, but the concept to make you aware of something. And that experiment sort of showed that this is indeed how is it working. So it's about of then discriminating between real world versus projected world. This is quite interesting and fascinating. What is the difference between the real world that you're experiencing and the projected world? When you go home today and you happen to discuss about this particular event, and you will tell the story of what you've seen and what you've experienced, you will basically reproject something that has been projected in your mind. But the real world at that point does not exist anymore. This is, at this point, that is past. The past might not even exist anymore, right? But you are basically telling a story, enriched with content and concept, and your audience, the person you're talking to, will basically understand and reproject in their mind a certain concept in the way how you describe to them. So that is the difference between the real experience and the projected world. Our mind works specifically as a projection of the real world. And we know that, we've discussed that, the world is unconsciously organized in our mind. And in fact, we can think about, and we talk about things that are just represented mentally in our brain. We cannot talk about something that it is not properly formalized. And that's the reason why if you take a child and you put a child in front of the slack, the linear accelerators, the child does not have information and knowledge about what is a linear accelerator, what does it do. So in his or her mind, there's no mental representation of a slack, of a linear accelerator. It's quite interesting to really restate that the projection of the world, it is indeed in our mind. And that actually takes to very fascinating readings if you want to enjoy some Friday evening about the fact that some people suspect that the universe is just a simulation, right? It's just a simulating what's happening, but indeed it's just, it is all a projection in our mind. Anyway, conceptual spaces. So here's the intuition then. We've seen, we observed what's happening, and how can we make this an application out of this? So what if you can geometrically represent a concept? How can we project into a multidimensional space? We can work with the concept extraction. We can try to see whether we can build up a topological space where dimension and distances and concept are all in there in this geometric environment where all the concepts are interconnected through inferences. But what is a concept? A concept is an abstraction of an idea, a thought, an expression, an object. So it's not about a word. And in fact, we can say that democracy, a single word, is a concept, right? So a concept is something that we can describe and that has a mental entity in our mind. Or it could be a short phrase like quantitative easing. So it's not even one word, it's two words. It's about a monetary policy tool, issued by the central bank that does such and such. This is a concept. It's not even a tangible concept, by the way, right? But as long as we understand what the quantitative easing is, so that description, we can call quantitative easing Mickey Mouse. Who cares, right? Mickey Mouse in the monetary policy. But the concept is not about the label. It's not about the words. And it could even be a long phrase, the decline of Roman Empire. That is a concept, right? That describe, the decline of a certain type of empire, in a certain historical context, and so on and so forth. So concept is a mental abstraction, again, that could be an object, but as long as it is projected in our mind. So let's look at an intelligent framework capable of reading the structure of any data source and understanding the meaning, identifying concept, the definition, the meaning of the concept, like a democracy, as we've seen before, and mapping them in a structure similar to our brain. So World War II is a concept as much as Illuminism is a concept. If we can vectorize it through a neural network and try to project it, then we can start mapping them geometrically into a space. And Illuminism and World War II will be projected somewhere else differently, in a different space. And that is just the beginning of the build-up of a semantic space. What about disambiguation, which is a very annoying problem that we've been suffering with NLP? So what is a jaguar? I can read and try to understand. I can try to enter into the context. And the jaguar could be the car or the cat, depending on the context in which we are talking about. If we're walking on the San Francisco Zoo and you hear me say, oh, this is a nice jaguar, chances are I'm referring to the cat. If I'm just leaning on the window now and I say, oh, this is a nice jaguar, hopefully I'm referring to a car. But it is about really understanding the meaning and the projection of this concept, and eventually projecting those in the semantic space in a different place. So that is what's called a semantic disambiguated space. So we know that the vector representing the concept jaguar the cat will be projected somewhere, and jaguar the car projected somewhere else. So the creation of semantic space at this point, it is an easy job, right? We just need to read, and iterate this process through the concept universe to build up the entire semantic space. So democracy, machine learning, linguistic deep learning, bioinformatics, human rights, Renaissance, the Middle Ages, everything is a concept. Everything eventually is projected over and over again to the semantic space. And guess what? Doesn't that resemble the brain of the people that we've seen like a few slides ago? the more we read, the more we grow older, the more we understand, the more concepts are projected in this semantic space, synthetic, and that is where hopefully the entire human knowledge can be synthesized. Not only that, a concept evolves over time. Think about the concept marriage. Would you agree that, if we talk about marriage, everyone agrees what it's all about, is the union of two people. But in the Middle Age, marriage had certain meanings, or before Christ had a certain meanings, and today is a different meaning. It's always the union of two people, but today we accept marriage of the same sex. That, of course, was not in the Middle Age or before. So over time, the same concept may vary in nuances, and the projection will be reflected as well. That's great, because if we can take the same concept across time, we will see the difference. Maybe the concept will be very much close to each other, but the slight difference will again highlight the differences, the nuances of the concept over time. This is also a language agnostic framework, which is great. So we don't need that point to enter too much into the troubles of translations. We can actually think about a mathematically called isomorphism, so a semantic space that they said you have a Chinese vector space with a certain concept projected, like Microsoft, Apple, the company, and pair. And I'm pretty sure you understand the trick now. And then Apple and Microsoft, the pair in English, right? Why pair? Because pair could be associated to apple, the fruit. But at this point, these are two vector fields, and who cares what they represent? We can join them together and roto-translate. And the transformation is about a new, richer field that basically has intrinsically both Chinese and English. And we can do this with every language, you see. You have apple and pear, and the equivalent in Chinese, but then you're bringing Apple, the company, with other type of informations. And the more you do this, the more you enrich the semantic space to create a more dense semantic structure in different languages. And this eventually is about extracting inferences. So I can read all the possible type of information. I can feed and build up a knowledge graph, so a semantic space, and try to segment it by topic and domains, and eventually utilize both quantitative and semantic layers to the end of extracting an inference, so a concatenation of concept. But what is a knowledge graph? So if we read all these kind of things and we put them together, what is a knowledge graph? Well, what it is not, first of all. It is not a static representation of entities. It is not a visualization tool. It is not a map of resources. A knowledge graph is rather something more complex and more knowledgeable, as the word says. It is something that, in a way, represents the projection of semantic interconnected concepts, a space where relationships are shown and explained, a multi-domain framework where inferences are built. Let me show you what it is not, a knowledge graph, or a portion of it. It is not something like this, where basically you just link a few concepts with no particular explanation, or maybe with some keyword-based link. So this is a static representation of information, not much knowledge in there. But what if you have something that is able to extract much more intelligence from the connections? Something that between Leonardo and the Mona Lisa, you can extract the inferences that connect these two concepts. And it could be many, many more. So you are enriching this link. And then you can enrich also the link between Mona Lisa and Renaissance with similar informations that remain pertinent to the beginning of the chain, right? So you don't want to have two separate segments. If you read it through now, you can see the entire synthesis of a proper inference that connects Leonardo da Vinci with Mona Lisa and Renaissance work. The more we read, the more the system becomes intelligent and knowledgeable. So it is about an infinite content universe, and starting from what is vetted and starting from amazing sources. And the more we read, the more that big graph becomes richer and denser and intelligent. So the induction of a knowledge graph is reading everything possible, possibly vetted information, quality information, and induce through the technology that you've seen a minute ago, a knowledge graph. A knowledge graph that will eventually take you to an adventure of extracting information, inferences, and build up knowledge on a specific domain. It's not just a theory, by the way. We've been working with this for a few years now, and we've done quite an interesting application in the field of life sciences, in the field of knowledge discovery, in libraries and the research field, and in the world of finance, where we have quite important applications, extracting information, extracting inferences with economic and financial models. And it's about transforming the information into knowledge, as we said. It's about creating this platform, this environment that helps you to devise and know more, and not just skim through a list of documents. So we have here just a few small demo. Discovery on Earth is about leveraging what we've seen like so far for the libraries and for students and faculties. In this case, user inquires for a given concept. This is not a keyword search, but it's about a concept. And part of the knowledge graph is visualized in order to show relationship and help to extract knowledge. So if I type, for instance, library science, I can land on a portion, a very small portion of the graph. I can see library science, and I can see the relevant concept behind that and around that. And I can see the definitions, and I can go through this and expand even more. I can...
Just a quick clarification. You said the knowledge graph is a visualization, but
it is not a visualization.
It
is not a visualization tool.
It's not a tool.
The knowledge graph is not a visualization tool. The knowledge graph is something more. It is a space, is an environment where information is correlated through their relationship. A visualization tool is a tool, right? So you can visualize a knowledge graph, but a visualization tool is not per se the knowledge graph.
So it's not an end product. It's a process of the question that you ask back to the
is the dress, right? Is the dress of the real product. The knowledge graph is your looking like a database, which is not a database. Is something much more intelligent than a database. But for inquiry knowledge graph, you can do through a visualization tool, or you can do through certain algorithm that just spit out the answer for you.
This safe to say that the most common way to visualize a knowledge graph is with a graph.
Yes, the problem is that the knowledge graph, the real knowledge graph, is multidimensional, right? The connection between any two concepts are multidimensional, so you can't really describe it even in 3D. So that's why you try to flatten it, and that's why it's very important not to confuse visualization tool of a knowledge graph as a knowledge graph. It is your window into the knowledge graph, and you can see just a portion of it. We've seen a few slides before that this knowledge graph is language agnostic, so you can build a multilingual knowledge graph. In our case, we blended English, Chinese, and German by ingesting and processing English, Chinese, and German content. So you can indeed select the language that you want, all of them, and still the portion of the knowledge graph is represented by adding new concept, and you can really jump through one language to another one and find this amazing enriched portion of the graph where you have concept in different languages. And of course, it's meant for you to know the languages.
So how does this handle example, idioms from other languages, because those are very conceptual, but you can't really put a lot of.
Very good question. How would you define an idiom?
So there's a lot of different idioms for different cultures,
Right, right.
If you're talking about this being content and language agnostic, there's a lot of content written in Klingon. That's my favorite example. It's not real, but it is to some people. There are idioms even in Klingon. So how would you address those kinds of concepts?
Absolutely. And an idiom is just a conceptual representation of some information, right? So it doesn't really matter, if you focus on understanding an idiom, it means that you want to enter into the lexicon and the syntactic form of an idiom, right? In order to understand why in a certain language you're trying to express something in which you would understand in another language. But the way how the system understands an idiom, it is basically not even bothering describing this as an idiom. It's just a concept extraction. And a concept extraction is about abstracting the concept by reading this definition, if you have it, or the context through a topic model. So whereas the idiom appears in a given text and in other, of course, form of documents, the projection of the concept will eventually create, imagine that you create a small cluster, and the meaning of an idiom will be inferred. That's why you heard me saying a couple of times is an inference engine, right? Will be inferred by other examples. 3 questions.
I was going to have my hand up first. So, to respond to our question, that's a good example. An idiom has a certain kind of, and we talk old-fashioned for has a kind of meaning. But what you just said is an idiom is a concept. That concept can include the fact that an idiom is a certain kind of differentiation or distinction from, quote, normal usage, right? It just means the concept is capacious enough. It'd be a certain kind of concept. A little different, right?
Yeah.
Something, your answer is that's what you're saying, right?
Yeah, and I would actually add the fact that
it can take into account the fact that an idiom is a marked distinction from normal usage, so to speak.
I'm just highlighting the fact that an idiom, it is the representation of some conceptual abstraction, right?
Yes.
And you can have one concept that is representing the idiom perfectly, or you can have a clusters, very dense, very tight cluster of concepts, which we call it, by the way, super concepts, that are representing the idioms better. And that actually is the beauty of a knowledge graph representation intrinsically, mathematically through a graph, through graph theory, because graph theory allows you to devise what is called emergent properties, where you can find this condensation, looking like a blood cloth sort of moment into the graph, where few concepts are very much tied together. And the fact that they are very tied together means that they are super concepts, means they are very much representative of another concept, which could be an idiom.
So you're extracting from all published data. How do you separate falsehoods, biases, irreproducible data? You're putting it all in your model. How do you differentiate those?
We don't differentiate because it is exactly why you want to ask in the Inquisition in the 16th centuries why you kind of trusted the Aristotelic books, collections, why you should trust the Aristotelic collection, right?
So if your model is built on a certain amount of falsehoods, your model is going to be false.
Yes, but the model will, not really, the model will adjust itself by correlating the inferences. So there are 2 ways to make the knowledge graph a proper instrument. First of all, the human intervention happens at the selection of the sources. And that's why we do not scrape the internet, but we ingest hundreds of millions of publications and books and collections, so on and so forth, which are recognized as vetted information. That is the first part. And the second part is it happens that there are papers that are written and published that eventually, after a few years, are proved to be false. would you discard them? Would you actually, if you are in charge of a library, would you go in the database and cancel from your database those publications that maybe PLOS ONE or Nature published and 10 years later proved to be wrong? You wouldn't.
No, they do. The major journals will publish these articles.
No,
43
just the false.
fraudulent.
No, exactly, the fraudulent. Just the false, not the wrong.
Or the dangerous, the gene sequence for influenza. Can I question your assumption?
It is not like this, because again, you're just now going to a very much detailed information.
Yes.
The volume is really too high. But anyway,
Ma'am, turn the volume down a bit, please.
it is about creating the. Okay, it's about creating the projection of the concept and how they correlate to one another. So if you find a correlations that eventually is leading to a certain result and a certain type of inference, first of all, this is not a machine that will give you the answer. So if you're looking for an oracle that, you ask the question, you get the answer and just go home happy, we're not there yet. This is a machine, like all the knowledge graphs, that allow you to describe and unfold the inferences as they have been discovered and written by authors.
So let me address your question in a slightly different way. I'm in the library business. We among us have lots and lots of people who collect materials. We do not censor what turns out to have been a false, misleading, or otherwise dangerous idea. We do not take on all of Karl Marx, all of Adolf
I'm
Hitler.
talking about fraudulent.
No, well,
Yeah, the
that's
fraud- yeah.
Fraudulent made-up data.
Okay, publishers. Let's talk about scientific publishers.
We
They
remove
will
it.
identify an article that has lost credits. They will identify it, but is not erased from the data file. It does not disappear. It is debunked by the editors, maybe with some knowledge about how the false ideas were assembled and presented, but it is not actually erased from the record.
But answer your question about fraudulent, the way how this system works is that this is quite transparent, because we get the publication from the content providers. So the content providers remove that article, automatically that will be removed from the knowledge graph. So this is it's completely transparent. The knowledge graph represents what is being published and what the community retain as a good work. If that content is not in the publication anymore, that will be equally removed from the knowledge graph.
I know knowledge management is a thriving field in artificial intelligence. Truth maintenance systems, I believe they were called in the 80s. And trust assignment is the sort of thing that might keep contradictions from resulting in the principal explosion where you can prove anything from a contradiction. My question is about the neuron. You said earlier when you were showing neural networks that they are identical to the biological neuron, but
They're similar, not
they're
identical.
similar.
Yeah.
There's an anesthesiologist in Arizona who believes that chemicals called tubulins put a quantum computer with some number of qubits per each neuron into the human brain. And that indicates that we should leverage the human brain as part of the process. So just like a self-driving car that can't find a parking space is like a knowledge discovery system that can't ask you questions back about disambiguation and such.
Right.
Are you familiar with Hans Freudenthal's 1960 Lingua Cosmica? It's an interlingua, supposedly for search for extraterrestrial intelligence, but this work has been going on for some time, and there's a Sylvan Bromberger book on how we know what we don't know, which is a way to perform the truth maintenance function. The one question I had is, do you think that we should build systems to find subject matter experts, to find the humans, to help the people who come into the library with a topic that they have a question about? If they're unsatisfied with the initial answers, is it good to drop them into a subject matter expert human discovery system?
Yeah, I mean, this is actually applicable for knowledge graph or any system that you develop for research and discovery, right? Subject matter experts are always need and in need of a more intelligent system that can help them out to do the work, in a better way.
I'm going to describe this as something that's using a neural network because you are dealing with the context. Going back to the truth or the reproducibility, because you're cracking open all the text that's already in there, and the context behind that. You could theoretically, there's actually another company that I think it went to conflict, maybe you can check up on it. They were looking at the linguistic properties of the text to see how truthful it was. They actually did this on speeches from Abraham Lincoln and Adolf Hitler, and they showed there's a whole lot of bad stuff in the Adolf Hitler one. Maybe you shouldn't trust that one. That's something you probably might be.
I don't think that no one can do that. I don't think no one can do that. And I completely very skeptical of any machine, and not now and not in 100 years, that can really read a text and then disprove what is written. The only way to disprove it is that to be aware of facts and then create proper logic to disprove it. This is not actually the purpose, right? You are in the field of discovery, right? And you want to basically make sense of the huge amount of information that otherwise you wouldn't have a lifetime yourself, despite you're very young, to read all the possible information about any subject matter. And you want to find a cross-correlating element that links something on a given subject field to another subject field. And this actually is all about, the major discoveries have been found, not just scientifically, but in general, by connecting elements that were not so obvious. And then you can see this, how this can in fact do it, right? You start with one bubble there, and you can expand it one, expand another one, and you can bring in the picture another bubbles from different languages, which actually have their own environment, and all of a sudden you see this inferential. Remember that those lines are not just static links, they're not ropes. As we discussed, there are big pipes within it. You have the description of the inference, or why any two concepts are connected. And the two concepts are connected because it's been extracted by vetted sources. If you don't trust the better sources, you shouldn't trust it. You don't trust the better sources even by just go on +1 on Nature or Springer, right?
So I'm actually a user of the library, and I've tried to use that catalog many times, and this graph kind of pops up. Personally, I've never found it useful. I'm wondering if you have any user data and how people are using it and how.
Oh, we have plenty.
Sorry?
We have plenty.
So are you going to share that with us?
Not in this presentation. We can talk after this. Yeah.
How do you know when it's like experience enough? You said what things to read and learn, I guess. How do you know like when it's done, or does it just continually evolve and you then?
It will never be done. And the more information keep on being produced and knowledge keep on being aggregated, and the more you read and the more you aggregate data and you correlate data. And this actually is about the ability to really construct a new piece of knowledge and information and feed the system accordingly.
What is the gatekeeper on deciding what's a concept and what's not? And knowing the language, obviously, but obviously you're going to throw out pronouns and.
Is the system itself that recognizes in the semantic structure what could be a concept and whether a concept has a meaning or a definition. So you can have a concept that has been dealt before and you have a definition of it, or you have a new concept. As you can tell, there are many more concepts than words or things. We can invent a concept today ourselves, and we can make a description. So the first time that a concept is identified in the semantic structure of a sentence or a piece of text, it is put in a sort of like a limbo, in a candidate state, where the definition is being tried to carved out by the context in which the concept is dealt with. And if you find a concept once, that is not enough, but when you can start correlating and bringing other concept, projecting the concept into the semantic space, you will start giving certain type of definition and description until the concept over time becomes more precise.
An author is always going to end up to be a concept.
Say that again?
An author is always going to end up being a concept.
an author. A concept could be anything. It could be a person, it could be an author, it could be an object, it could be a sentence, as we've seen before, a mental structure, anything. A concept is something that you can describe in a way. That could be tangible or intangible, abstract or not.
Gabrielle, do you have some?
I have two. One is a statement and one is a question. Statement first, it would be helpful to have a list of publishers and ideally title level information, what content is in UNO. The second one is a question. Can you provide real world examples or applications of how AI has or will change libraries?
Okay, well, I hope this one could be one that answered the second question, and I'll show you a few more applications in a minute. And the other point was about the list of yes, we had UNO today have more than 200 and maybe 30 million content coming from a very large list of content providers, as we said before, all vetted. Yes, be happy to provide this. So you can again browse and navigate through this graph, expand nodes, and there's no limit. You can keep on clicking on those bubbles, and a new branch of the graph will be displayed, and then again, and you can really create your own path and journey through correlating concept. And you can even, of course, retrieve a piece of information, of course, so you can access the content itself. You can see the snippet where the concept in particular has been dealt, and you can access that in a very detailed fashion. You can go through every single of those little elements, and of course eventually you can link it back to the real full text source through any link resolvers through to the holdings. And if the user is legitimated to access the full text, it will access the full text. You can even work at the publishing level or library level when actually libraries also publishers. So basically creating a topic structure. All of you guys are very familiar with the taxonomies and the strength of current taxonomies, but at the same time the limitation of current taxonomies. This system, by definition, is creating a fine-grained new taxonomies that, of course, we map with existing taxonomies, but you can go very much into details of not only the book, but even at the chapter level. So any given book you can access because the concept base, you can really retrieve the topic, you can carve out the taxonomy of the topics at the chapter level and identifying if any given chapter is about a certain topic or another topic, and that has been quite useful to create collections. And finally, you can really create your own map. And I discussed like a minute ago about how to map existing taxonomies with our hierarchical topic model, because we deal with topics as a concatenation of concepts. So if you slice down and create this stack of topics hierarchy, at the very bottom there are the concept. Concept, single concept, you aggregate some concepts, you have subtopics, you aggregate other subtopics and subtopics, and so on and so forth, until you get to the main topic. We discussed about life science, and that is maybe one of the applications that is proved to be quite important in finding remedies for certain type of disease, utilizing the same mechanism, more or less, with a different type of approach, but is an instrument to investigate biomedical relationship. And given a knowledge graph, you derive relationships, and eventually you map this relationship into an application that is similar to what we've seen a minute ago. And this is pretty much an application that is sold to medical schools or biotech companies. Is working very similar. It's access knowledge graph that specifically is a biomedical knowledge graph. You can find molecule, you can find biological elements like genes, proteins, and other type of concept. And you can also delve into much richer structure at the molecule level, as you can tell. you can see drugs, you can see interactions with other drugs or other biomedical components, and you can even access, as you will see in a minute, clinical trials. Clinical trials is, again, publications, right? Informations that are structured information that if you are able to ingest and cross-correlate, you will be able to see exactly how a clinical trial behaved, the description of it in the context of your original conceptual search. Yes.
Is the visual graph that you've been showing, knowing that the graph is not a visual, are there other ways to interact with it? And the reason I ask is because being a previous medical librarian myself, I've got many medical librarians, they don't actually like the graph part. So is there a way to interact with it instead of the graph?
Yeah, they don't like the graph. I can disagree, because we found many of those that actually they love the graph, particularly in the kind of exploration of things and finding correlations. But yes, there are many other ways, and in fact we released APIs, for instance, that basically inquire knowledge graph accordingly and spit out a certain type of query. Finally, this is something that we are working on. It's a new project. It's about open knowledge. So the ability to potentially arrive at some sort of machine-generated content. And this is something that, it is somehow feasible. As you know, most of the information that we are exposed to and we read and we learn is through the structure of the language, through the language, which has an intrinsic structure. And you hear me about talking, so there is like a phonetic component that transforms into phonology, morphology, semantics, and pragmatics. So depending on what layer you land, any type of form of communication, written or oral or sound, think about dolphins, how dolphins communicate to one another, they follow pretty much the same type of structure, brings and leads to the upper three layers, which is the syntax, the semantic, and the pragmatics. The goal is to develop a system, a framework, to generate automatically content based on existing literature. And the challenge is that basically is what to write, that is called information selection, and how to write it. So basically it is the issue of having something that is coherently put together. And the approach is by leveraging what you've seen so far, plus few more things that pertain hierarchical topic embedded, coherent thematics algorithms, and generating this block of content that's actually blend together quite nicely. State of the art today, we're not the only one that actually started doing this, but the current solution typically deal with broad categories that falls in three families. Rule-based, which are text-generated, typically is the if-then rules, very ontological. The prose is less sensitive to noise. Everything actually falls into what is being ontologically described, but the output is very limited. The second is an AI approach that is planning-based. Planning is the process of identifying the sequence of one or more action and then try to put them together in a kind of communicating goal. Much better, actually works and not bad, but it's very high in computational cost and the maintenance of it. So it kind of is not robust enough. And the third one is the database, which is a text generation through machine learning models. You need a very large set of samples and use very probabilistic context-free grammar, PCFG. Very powerful, but very much statistical oriented and is like a black box. So the limitation is typically about a poor vocabulary, unusual structure of sentences, and most of everything else that the result automatically generates a text that sounds unfamiliar. You read it through, you understand that it's not written by a human, and is not blended very much together. We are making hopefully something better, and we are working with an adversarial generative model that leverages what you've seen so far based on the conceptual abstraction. The input is a set of articles, source, or any sources given in a period. And then you have the text generation through the generative adversarial network in abstractive, not extractive way. So there are basically two neural networks. One is called the generator, one the discriminators. They play against each other. And they continue to play against each other until one of the two is coming up with the piece of text that is most likely be indistinguishable by the original text model. We have done some interesting experiment. It's not ready yet. We're working on it, but we've done something like that, just know as a game. Try to read this. It is quite an interesting poem that actually has been written by this algorithm. And it's been written by simulating the style of an author. What we've done, we taught the machine to extract a topic, melancholy, love, sadness, or whatever, choosing a style that had been, of course, extracted, and then teach the machine how to concatenate concept and inferences, the inferences, as we've seen in the previous examples, and try to make recurring patterns. And eventually that led to the description of that poem and other piece of text that we found quite interesting to pursue the machine-generated activity. And that actually closes my presentation. More question, please. Yeah, question.
Is there a way to recognize if somebody is searching for something that they think is a concept or a thing that you have not ingested enough?
Yes, that's a good question. Yes, absolutely. And we analyze the type of queries that come into the system, and we can see not the result necessarily that has been displayed, but whether there are patterns that will fall into the topics. Yes.
About the labels you use to describe concepts.
Yeah.
So I know the knowledge graph is involved around concepts, not necessarily words, but it looks like you have kind of a preferred label that you're presenting to users. So how do you settle on what that label is?
Yeah, the label is basically also defined by the fact that the concept is describing itself. So when you see, let me give you this example. Using that platform, there was this student searching for Black September, which was a nasty story of a terrorist attack in Munich in 1972, where the Palestinian kidnapped the Israeli team. Anyway, the concept that was emerged from the graph, was one of the bubble, was an entire sentence, was Operation Wrath of God. A long sentence, which incidentally was the code name that the Israeli gave the Mossad for retaliation against the Palestinians. So the Operation of God, there's no such a thing like a dictionary that says Operation of God is the retaliation of God. But Operation of God was obviously a concept that was repeatedly dealt in all the literature describing those events. And the system recognizes like, sounds like a concept. And as a concept, when you project it into this semantic space, either is completely influent and will be like a lonely guy somewhere in the space, or be very much tied to other concepts like Black September, like Intifada, like Mossad, like other things. So this is where the concept gain relevance and importance, and the label, it is what has been extracted, it has been how it's been recognized.
Okay, thank you very much.
Thank you.